and welcome back to Introduction to Physics Labs. My name is Paul Eric, and today we're going to be doing Lab 1.9a, which is entitled Simple Machines. So in our previous lab, we discussed what energy was, and in particular, we discussed what potential and kinetic energy was. So we're going to be using the concept of work in order to explain simple machines. So our purpose is to first define what work is and also to see how it's related to simple machines. And then we're also going to learn about how a lever works, and then we're also going to learn how a ramp works, and then we're going to learn how a pulley works. So under the procedure, let's first just do a little bit of background on simple machines. So a simple machine is going to be a device that can change the force, the distance, the direction, or the rate that is applied. So for example, a lever, so a lever is shown in that diagram down there, like this. You push on one side over here, and then the other side goes up. And in general, you want to apply a little bit of force on this side and then cause it to be able to lift something really heavy on this side. So it's going to increase the amount of force that you apply. Okay, number 2 says that it can also change the distance. Now, normally, this is not something that you want to do, but salad tongs are an excellent example of this. So that let's say that you got your baked potato is located over here and you are over here, and the problem is that the sneeze guard is in the way so that you cannot reach that baked potato over here. But if you've got salad tongs, and so the idea of a salad tong is it's going to be kind of shaped like this, and you grab the end of the handle and then you can reach that baked potato over there. So that would increase your distance, that particular kind of simple machine. And then the third one is a pulley. And so if you have a pulley here and you are trying to lift a very heavy object, then what you can do is you're going to pull down. So you're going to pull down on this rope here, and it's going to lift this object up. So it's going to be changing the direction that you are applying the force. And then the fourth one is think about the gears on your bicycle, so that you have a set of sprockets on there. And then what can happen is that it can change the chain. So instead of the chain going around this sprocket, it can go around this sprocket up here. And so the idea is that's going to change the rate at which you're going to be pedaling. So all of these are different examples of machines. Now, we're basically only going to be interested in this category right here, where we're going to be changing the force. But I did want you to realize that there are other kinds. So here's the different kinds of machines. So we're going to be looking at the inclined plane today, the lever. Okay, now this one is a wedge, which is actually, if you take the inclined plane and you insert it into a piece of wood, that's essentially what a wedge is. Then you also have a screw, which is kind of a rotational lever. And then you have the wheel and the axle, and so this is kind of similar to the sprocket thing up here. And then you've got the pulley. So today we're only going to be doing the inclined plane and the lever and then the pulley. And so if you're interested in the wedge and the screw and the wheel and the axle, you can find that on the internet. So how do these things work? So they all work under the principle of conservation of energy. So we talked about conservation of energy in a previous lab, and we said that conservation of energy meant that you put in a certain amount of energy, and then a certain amount of energy is going to come out. Now, if it's conserved, the exact amount of energy that you put in is what's going to be coming out. But we're going to find, though, that these machines do not conserve energy, that you always have to put in a little bit more energy into your machine than what you're going to get out. But for purposes of demonstrating how the machines work, we're going to assume that they're perfect machines, but then when we actually look at them, you'll see that they're not exactly perfect. So the conservation of energy is going to say that the amount of work that you put into a machine is going to equal the amount of work that comes out. And then work is going to be defined to be force times distance. So we learned this in a previous lesson, that work, W, is equal to a force multiplied by a distance. And I tend to use the letter R to represent distance. Now, there's also this concept of efficiency, which I'm not really going to emphasize too much in this lab. But I mentioned that you always have to put in a little bit more energy into a machine than you get out, because some of the energy that you put in is going to be turned into friction, and it's going to be wasted. It's going to turn into heat, and then it's going to escape. So you always have to put in a little bit more. So the efficiency is the amount of work that comes out divided by the amount of work that goes in. And since you always have to put in more energy into the machine, that means that the work in is going to be greater than the work out, which means that the efficiency is always going to be less than 100%. Okay, so you're going to see that we're going to use this concept of force times distance going in equals force times distance coming out. That's the principle for basically all of these machines that we're going to be talking about today. So it's very, very important. So let's take a break, and when we come back, we're going to start with our first machine, which is going to be the lever.